All right, so let's continue section 7.2. This is the third part of this section. Okay. So in the previous parts, in the previous two videos in this section, we studied the sum and difference formula of sine and cosine and tangent. Now I'm going to do more examples in this part, okay? So, I move you here, hide video. Okay. All right. Next example is saying find the exact value for secant negative 11 pi over 12. And to get secant, right, we should find cosine because secant is 1 over cosine. So this is exactly equal to 1 over, oops. Oh, why are you doing that? One over cosine of negative 11 pi over 12. So it's enough to find cosine of negative 11 pi over 12. And negative 11 pi over 12, let's convert it to degrees, times 180 over pi. I can cancel out pi's, and I can simplify it. 12 and 180, I will have 15 here. So it is negative 330 degrees, okay? So we should find cosine of negative 330 degrees. Wait, it is not 330, right? Sorry, so it's not negative 330. What does it make? 165, yeah, sorry. Negative 165 degrees. Okay, so I should find negative cosine of negative 165. But first of all, we know that cosine is an even function, right? So it is aiding the minus. So cosine is an Hungarian function in our analogy in the previous videos. So this is exactly equal to cosine of 165, okay? And we know that 165 is 210 minus 45. Cosine of 210 minus 45. And we know that 210 and 45 are the angles of spatial triangles. So I have to use the difference formula for cosine. Remember that? What was the formula? If it is cosine, it's always starting with cosine in the first two terms. So cosine 210 times cosine 45. And if it is minus here, it should be plus here, right? Plus. Now I have to switch the function from cosine to sine, right? Sine 210 times sine 45. So we should find what cosine 210 and what sine 210 is. But we have already studied this angle, right, in the previous page. Let me show it to you. Was it here? It was, I think, here, yeah. 210 is here, right? So cosine of 210 is negative root 3 over 2, and sine of 210 is negative 1 over 2. So, with knowing that, so this is actually equal to cosine 210 is negative root 3 over 2 times cosine 45 is 1 over root 2 plus sine 210 is negative 1 over 2 times sine 45 is again 1 over root 2, right? Now they have the common denominator, so we just need to look at it. So we can sum them together because they have the common denominator. We can sum up the numerators. Negative root 3 times 1 is negative root 3, right? Negative root 3 plus negative 1 times 1 is negative 1 over 2 root 2. Okay, so but okay, this is not the answer, right? Maybe I can move my rectangles because I just put box around the final answer, but it's not the final answer, right? This is cosine of negative 165, but I need to find the secant of this angle. So I just need to flip this, right? So it will be 2, oh, come on. Okay, just flip this number, 2 root 2 over negative root 3 minus 1. This is the final answer, okay? I hope it is clear for everyone. This is the final answer. So let's move to the next example. Find the exact value of sine of alpha plus beta if cosine alpha is root 5 over 5, sine beta is negative root 3 over 5, and the terminal side of alpha is in the first quadrant, and beta is in the fourth quadrant. Okay, these are important information first, but before working on them, let's look at the sine of alpha plus beta. We have to use the sum formula right here. It is sine alpha times cosine beta. And if it is plus here, it is plus also here. Plus sine beta times cosine alpha, right? So we know what sine beta and cosine alpha is, but we should also find what sine alpha and cosine beta is, right? Okay. All right, so what I know about alpha is cosine alpha is root 5 over 5, right? And on the unit circle, remember, cosine is always x, sine is always y. So for alpha, x is root 5 over 5. And to get sine, I need to find what y is, right? What is y? I don't know. But what I know is between x and y, x squared plus y squared is equal to r squared, and in the circle, it's equal to 1, right? So, and x squared is root 5 over 5 squared, which is 5 over 25, right? 5 over 25 plus y squared is equal to 1. So, and I can simplify, right? This 5 over 25, it's 1 over 5. So y squared is equal to 1 minus 1 over 5. And if you have the common denominator, it will make 4 over 5, right? So from here, y is equal to plus or minus root 4 over 5, which is equal to plus or minus 2 over root 5, right? Should I pick root 5, plus root 2 over root 5, or minus 2 over root 5? And to decide that, we have to check this information, right? Alpha is in the first quadrant, and sine is positive in that quadrant. That's why I have to pick the positive value, right? So y is equal to actually 2 over root 5, okay? This is for alpha. So sine alpha is 2 over root 5, okay? And I should also find cosine beta, but similar thing, I have to follow similar steps, right? For beta, I know sine beta, right? So y value is negative 4 over 5. X value is unknown. And x will be given the cosine beta, right? This is what I need here in the formula. Again, I have to use the Pythagorean theorem. And x squared plus y squared is equal to 1. So x squared plus negative 4 over 5 squared, which is 16 over 25, right, is equal to 1. So x squared is equal to 1 minus, okay, sorry, 1 minus 16 over 25. And if you have common denominator, you will get 9 over 25, 25. So I don't have enough space. Let me write down here. Maybe I can write down here, there, but here. x is equal to, I am out of the paper, but I can do that, a plus or minus root 9 over 25, which is 3 over 5, right? 3 over 5. Again, there we have two options. It is either 3 over 5 or negative 3 over 5. And to decide which one is the correct one, we have to check the quadrant of that angle. And beta is in the fourth quadrant. And in the fourth quadrant, cosine is positive. So x is 3 over 5, okay? All right. Okay, so now we got sine alpha and cosine beta, right? So let's just plug them here. So sine alpha is the y value of alpha, right? Which is 2 over root 5. 2 over root 5 times cosine beta. Cosine beta is already given, right? No, cosine beta is the x value of beta, which is 3 over 5. 3 over 5 plus sine beta, which is negative 4 over 5, times cosine alpha is the x value, right? Root 5 over 5. And I can simplify that, right? If I can divide both sides with root 5, and it will make 1 over root 5. So times 1 over root 5. And if I just multiply these fractions, 2 times 3 is 6. And if you realize that the bottom parts are same, so the denominators are same, so we have the common denominator, which means I can combine the top part, plus negative 4 times 1 is negative 4 over 5 root 5. So which is 6 plus negative 4 is 2 over 5 root 5. Okay? So sine of alpha plus beta is 2 over 5 root 5. All right? I hope this is clear for everyone. And let me continue. In here, I'm gonna just review some co-function identities. We have already talked about these identities before. So sine, okay, here is the deal. If there is pi over 2 here, right, pi over 2 minus theta, you just change your function with the co-function and just get rid of the pi over 2 part, okay? So cosine pi over 2 minus theta is sine theta. And similarly, sine pi over 2 minus theta is cosine theta, okay? If there is pi over 2 here, as you see all here, you just change the function with the co-function. And you should just keep the theta. And you should also check whether that co-function is negative or positive. Actually, whether the original function is negative or positive in that quadrant. But in this case, if theta is an acute angle, these are all in the first quadrant, so they're all positive, okay? And this is also true for tangent, cotangent, secant, cosecant, cosecant, secant, cotangent, and tangent. All right, let's look at this example. Write cosecant pi over 7 in terms of its co-function. So cosecant pi over 7 is equal to secant pi over 2 minus pi over 7, right? I'm using which one? I'm using this one, right? This one here. And let's have the common denominator, secant. I have to multiply 7 over 7 here, right? 7 pi minus, and 2 over 2 here. 2 pi over, and the common denominator is 14. So it is secant 5 pi over 14. So cosecant pi over 7 is secant 5 pi over 14, because pi over 7 plus 5 pi over 14 is pi over 2. Okay. With this example, I am done with this section. So we finished section 7.2. We finished section sum and difference formula for sine, cosine, and cotangent. Sorry, tangent. And to find cotangent, secant, and cosecant, you can just use the sum and difference formula for sine, cosine, and tangent, right? Because they are just reciprocal of each other. All right, so I'm gonna stop for today. And Okay, so wait a minute. Okay, I think it is, no, not this one. Yeah, I can end the meeting. Okay, see you in the next time.